All right, I think it's recording now. We got section 4.1, sample spaces and probability. So we finished chapter 3. We got chapters 1, 2, and 3 in the first unit. That was over descriptive statistics. So in chapter 4, we're going to begin our unit on probability. So chapter 4 is kind of a basic probability chapter. And in section 4.1, we're going to look at what are called sample spaces and just look at probability. So what is probability? So probability it's actually not a field of statistics. It's not part of statistics per se. It's part of mathematics. So probability is a field in math that's concerned with chance. So what is the chance of something happening? It overlaps a great deal with statistics, though. Statistics employs probability quite a bit. So we want to look at some probability here. So, yeah. First of all, we want to use a term called probability experiments. So we have some context for what we're doing. Throw out some terms. What is a probability experiment? It's a chance process. That leads to well-defined outcomes. So examples. Tossing a coin, right? That's a probability experiment. There's a chance process, and it leads to well-defined outcomes. Heads or tails, right, are the outcomes. Rolling a die. A die is a singular of dice, right? Dice would be 2. A die is just 1. So a die has 6 sides, right? 6 sides. You roll a die and you land up on one of the sides. 1, 2, 3, 4, 5, or 6. And it depends on chance, which one you roll on, you land on. Drawing a card. You got a deck of 52 playing cards. You draw a card. What card you get is going to be randomly determined. It's a chance process. Some other ones. Playing Wheel of Fortune. When you spin the wheel, what does the wheel land on? Playing Spin the Bottle, stuff like that. Anything that involves chance and has well-defined outcomes. Okay, so here's a term you'll hear a lot, sample space. So this is not the same thing as the sample in statistics. A sample in statistics, remember, is a subgroup within a population. A subgroup within a population. A sample space, this is for probability, a totally different field of study. But a sample space is the set of all possible outcomes. The set of all possible outcomes in a probability experiment. So for example, we often call a sample space, we use the letter capital S. So for tossing a coin here, we're going to call capital S the sample space. You get heads or tails. So in those curly braces are those they look like parentheses, but they're not quite the same. Anytime you see these curly braces, these things, that means you're dealing with the set. So we're talking about a set of outcomes. What are the outcomes? Heads, tails. So we just list all our outcomes. About rolling a die. I put a bullet there. So the sample space there, you get 1, 2, 3, 4, 5, or 6. Those are the possible outcomes. As far as drawing a card, the sample space would be all 52 playing cards. So the 52 playing cards, the 52 cards. And Wheel of Fortune, I don't know much about Wheel of Fortune. So Wheel of Fortune can be different. The sample space can be different depending on your wheel. So we're not going to talk about Wheel of Fortune sample space. All right, so what do I have? Can I scroll that? Yep. So what's an event? It's another term you might hear thrown around. There it goes. Event is a particular set of outcomes. In a probability experiment. So all possible outcomes in a probability experiment is called the sample space, but a particular set of outcomes that you're interested in is called an event. So for example, if you're interested in getting heads, then your event would be heads. If you're interested in getting tails in a coin toss, then your event would be tails. If you're interested in rolling a six when you're rolling a die, then your event would be the set containing six. Okay, so just some terminology. So an event is a particular set of outcomes you're interested in getting in a probability experiment. Okay, so anytime you see this, P of E, this means the probability of getting an event, E. That's what that means. Okay, so some rules for probability. Rules for probability. Number one, probabilities of events. It's P of E. Probability of an event is always between 0 and 1. The smallest the probability is 0. The smallest the probability can be is 0. That's if it's impossible, right? If it's impossible something's going to happen, you say a 0% chance that'll happen. So the probability is 0. The most the probability can be is 1. That's if it's a 100% chance of happening, you say the probability is 100% or simply 1. So you can't have negative probabilities, and you can't have probabilities bigger than 1. Number two, the sum of all disjoint. Now, let me put it this way. The sum of all probabilities, of disjoint events is equal to 1. So let's say I had a bunch of disjoint events. So all the disjoint events in the sample space, if I took the probability of each of those and I added them up, it would all add up to 100%. That's what I'm saying here. 1 is 100%. All right, let's actually do some... Oh, one more thing we need to do. Law for calculating probabilities. This is the law we're going to use. The probability of an event, let's call it E, is given by, we're going to use P of E for the probability of E. It's N of E divided by N of S. Now N of E, that's the number of ways that E can occur. Number of ways E can occur. And N of S, what's that? That's the total number of outcomes. total number of outcomes, or the number of ways that you can count the sample space. Remember, the sample space consists of all the outcomes. So when you tally all those ways up, tally up all those outcomes, you get n of s. So n of e, the number of ways e can occur, divided by the size of the sample space, how big the sample space is. That's basically what we do. Let's actually do that. So finally, working some problems. Exercise. A fair coin is tossed. Once. Determine the probability of getting heads. Let me say A heads. All right, so let's identify the sample space. S, we're going to call it. Remember, the sample space consists of all possible outcomes. So we have a single toss. So your outcomes are what? Heads or tails. So we're going to write H, comma, T in the curly braces. And our event that we're interested in getting a heads, right? So we're just going to put H inside of a curly brace, right? It's a set. It's a set that consists of some outcome. What's the outcome? Getting heads. So when we're calculating the probability of E, it's the number of ways E can occur divided by the total number of outcomes for the sample space then. So n of E, there's only one way to get heads. That's getting heads, right? So n of E is 1. And n of S, well, we have a total of 2 outcomes that could occur. 2. So we got 1 divided by 2, that's 0.5, right? 0.5. So the probability of E is 0.5 or 50%, right? You got a 50% chance of getting heads on a single coin toss. Okay, that's all the symbols here. If you want to be really formal about it. Let's do another exercise. This time, let's do a couple of coin tosses. Let's roll a coin twice. So a fair coin is tossed 2 times, twice. Determine each probability. First, determine the probability of getting, we'll put a little colon there, right? Getting 2 tails. And then we'll figure out the probability of getting 1 tail. So keep in mind that we're rolling the coin twice, or tossing the coin twice. So first I'm going to write down my sample space. So remember, we're rolling twice. So what are the possibilities? I could get tails, tails. When I roll a coin, I could get tails, heads. I could get heads, tails. I could get heads, heads. So basically there are 4 possibilities. Tails, 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 heads, heads, tails, heads, heads. So those are all the outcomes. That's called my sample space. Now the event that I'm interested in, let's call it blue. I want to get 2 tails, right? That's my event right here. So that would be the set containing tails, tails. Now there's only one way to get tails, tails, and that's rolling a tails and then rolling a tails. So literally that single ordered pair, you can call it tails, tails is an ordered pair. So the probability of E is the number of ways you can get E divided by n of s. N of s is the total number of outcomes. So n of e here is just 1, right? And n of s, there are 1, 2, 3, 4 different outcomes. So 1 in 4, you have a 1 in 4 chance of getting 2 tails. So you can say probability of E is 0.25. Let's convert it to a decimal. We're going to use decimals, I guess. I'm kind of a decimal guy when it comes to probabilities. Yeah, so I prefer decimals when I'm doing probabilities. Now, let's talk about getting 1 tail. So our sample space is still going to be the same. You still have the outcomes of tails, 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 heads, heads, tails, and heads, heads. You still have those possible outcomes that can occur, but this time your event is different, right? You want 1 tail. So let's think about that. You could get what? Tails, heads. That's one way to get 1 tail, or you could get heads, tails. That's a second way. So you got 2 ways, it looks like, to do that. Tails, heads, and then heads, tails. So if I'm looking at the probability of this event getting 1 tail, probability of E, it's the number of ways that E can occur divided by the total number of outcomes, N of S. So how many ways can E occur? 2, right? 2 ways. You got this way, tails, heads, or you got this way, heads, tails. You just want 1 tail. And how many ways can, how many total ways, how many total outcomes are there? 1, 2, 3, 4 still. So 2 and 4 is the probability of getting 1 tail. Now let's reduce that to a decimal. 2 divided by 4 is 0.5. That's 0.5. Or you could say you have a 50% chance of getting exactly 1 tail if you roll the die twice. I think we'll stop there and we'll pick this up later.